All right, hello everyone. This is the beginning of the third part of the video for section 1.2. And I want to make sure I stay on this slide for a few minutes because this is one of my favorite memes. I guess this really isn't a meme, it's a GIF, but it's just very entertaining to me. Hopefully none of your grades are actually doing this a little early in the quarter for that to be happening, but still worth laughing about. All right, so continuing on with our study of section 1.2, we're going to take this idea of domain and range and focus a little bit more on domain with a different type of function that we haven't talked about yet. So this is what is called a piecewise function. And so a piecewise function, as you can kind of see from the definition here out of your textbook, piecewise function is a function for which different parts of the domain use different formulas, okay? And the way these are really usually set up, as you can kind of see from what is written there, so it'd be something like f of x equals, and there'd be a big open or curly bracket there. The first formula and domain for which you use that, second formula, domain for which you use that, third formula, domain for which you use that, and so on and so forth. Now, a piecewise function doesn't only have to have 3 different formulas. It could have just 2. It could have more than 3. It could have an infinite number. But this is just kind of an example or a general idea of what they look like. Okay. Now I know that's kind of vague, so we're actually going to set up a piecewise function. So we're going to use this graph up here to write a formula for a piecewise function. And before we do that, the other thing I want to mention is a piecewise function. It's called that because it has different pieces. So hopefully you notice when you look at this graph up here, there are 3 different pieces, right? There's this first one here, then there's this one, and then there's this one. So this has 3 different pieces, which is what makes it a piecewise function. All right, so to write our formula, we'll start with, like they do below, f of x equals, put a big curly bracket, and then put in each of our formulas here. And we write the formulas, we don't actually need this y equals part, we just need the what it equals. So we have an x squared, a 6, and a 10 minus x here. And then we put these little ifs in here, and those will be followed by telling us when to use each of those formulas there. Okay, so for the f of x equals x squared, what values of the domain are we going to use that formula for? Well, notice that part of the graph starts right here at a value of, say, 2. And then it goes to the left, and there's an arrow showing that it kind of continues on. So it looks like it continues along this horizontal axis here forever, as we see that arrow. So what would that mean? What values of x are being covered by that function x squared? Well, it's starting at 2, and it's going for all values below 2. So how could we write that as an inequality? Well, it looks like it would be x is less than 2, right, to mean all values below 2. And are we including 2 here? Hopefully you just said no, right, because notice there's an open dot here, so we are not including 2 in there. So we use the formula f of x equals x squared for values of x less than 2, and that's it. Okay, for the next one now, where we have y equals 6, that dot there. What would be the values of the domain there? Well, notice it's just a single dot, right? It doesn't stretch out to the left or to the right at all. So it seems to be at just a single point. And what is that point? Well, it's there when x is 2. So here we would have x equals 2. So we use that output of 6 if we just have x equals 2. And then for the third part, where the 10 minus x is, we'll notice that it's stretched between 2 values, right? So there's an open dot here, which again corresponds to 2. and then a closed dot here, which corresponds to, what's that value there? 3, 4, 5, 6. So those values of x are going between 2 and 6. And because there's an open dot, we're not including 2, so it'd be an x like that. And then the 6, we see that there is a closed dot, so we are including that one, so we have less than or equal to. So we have 10 minus x if 2 is less than x, which is less than or equal to 6. Okay, and so this thing I'm about to box in black, this would be our piecewise function or piecewise formula for this piecewise graph here. And again, piecewise means that has pieces, and again, you use different formulas for different parts of the domain. And let's focus a little bit more on that last part thing I just said on the next slide. So here we're given a piecewise function, and how many pieces does it have? Right, it has 2 of them, right? This top one and this bottom one. They want us to use that to find f of 2, f of 4, and f of 3. Now recall again, these things on the inside, those are the inputs, so those are the things in the domain. As we just said before, the formula you use depends on where you are in your domain. So for example, we're finding f of 2. Well, notice this first formula up here, the x minus 4. We use that if x is less than 3. So in this case, is the value we're using as our input, is that less than 3? Yes, it is, right? So it tells us we will use this formula here to find f of 2. So we'll do 2 minus 4, which will give us negative 2. Okay, so f of 2 is negative 2. We go to do f of 4, the next one. Well, again, looking at our input here, it's 4. Is that less than 3? No, so we're not going to use the top formula this time. The bottom one here says we use this for values of x that are greater than or equal to 3. That does include 4. So then we'll want to use this formula, x squared, so we'll do 4 squared, which gives us 16. Okay? So in this case, our f of 4 gave us 16. All right, what about f of 3 then? Well, again, looking at the way the domains for each piece are described. So for the first part, it says we use that formula x minus 4 if x is less than 3. Here, our input value is 3. Is that less than 3? No, it's not. So we're not going to use that formula. So then the second one here says we use for values of x that are greater than or equal to 3. So is 3 greater than or equal to 3? Yes, it is. So we use that in this formula then. So we'll do 3 squared, which will give us 9. So f of 3 in this case would be 9. Cool? All right. Let us continue on then. So now we're going to just do a little bit more of what we did on the first slide about piecewise functions, is writing a formula given a graph, right? So here they don't tell us what to call this function, so I'm just going to call it, sorry. I'm not going to call it sorry. I'm going to call it f of x. Do equals, and then here's our big curly bracket. And then we have to look at, first of all, what are the equations for each part? Well, this first part here, hopefully either looks familiar from the first slide and or looks like one of your toolkit functions that I know you are studying diligently. And which toolkit function is that? Right, that's the quadratic one, so that's the formula x squared, except for I'm not going to write it in highlighter. It'll be x squared. And then the second part, okay, notice that's a horizontal line. Do you recall that's again one of our toolkits, and which toolkit is that? Right, that is the constant function. And remember, when you're finding the equation of a constant, it has to do with what is the constant output there, which in this case looks like it's 2, right? For every point along here, the output value is 2, regardless of what the input is. So that would just be f of x equals 2. All right, and then we have to write the domains for each of these, the parts of the domains they cover. So the x squared, we'll notice, again, this one goes between two values. It starts here at -2 and goes up to 1. So we'll use the x squared if, looks like I'm going to write it up here. Our values of x are between -2 and 1. And the -2, we have a closed dot there, so that's going to be included. So we'll have a less than or equal to. The 1 is not, so just a less than. So we use x squared if -2 is less than or equal to x, which is less than 1. And then for the second part, we use 2 if. We'll notice here, this one starts at 1, but then it goes bigger and bigger forever and ever. So it starts at 1 and goes up to positive infinity. And we're including the 1 because there's a closed dot there. So it looks like in this case, we're looking at values of x that are greater than or equal to 1 for that part. Okay? So this here is our formula for that. So again, f of x equals x squared if the values of x are between -2 and 1. And again, I just wrote that up there because I didn't have room for it. So that describes the first part of the graph, the left piece, that one I highlighted in green. Then f of x equals 2 if x is greater than or equal to 1. And that represents the part I highlighted there in red. Okay. All right. Last thing from this section. In page 30 of your textbook, which even if you don't have a personal copy of it, there's a copy available on WAMAP. From there, you can see an example of graphing a piecewise function from the formula. So that's something we didn't do. Given a piecewise function formula, graph it. All right, thank you for watching.